In this video, we're going to get some practice querying the Dynamodb table. So we created this AdventureWorks products bill of materials table in Dynamodb, which is, again, a document store database. And recall, there's very little metadata that we've given it, only the primary key. And now we're going to be able to do some querying. And there's really two ways to do what we think of as querying. One is using an operation that's called query, which is, as we see here. And the other is using an operation that's called scan. We're going to just do scan. But I'll talk a little bit about what's the distinction between these two. So you have your Dynamodb table. It's out in the cloud. Obviously, what that means is that there's going to be network traffic because data is going to be coming to you from the cloud. If you do a scan, you're going to be able to filter similar to with the select statement. And by the way, what we're going to be doing is kind of equivalent to what the select statement does in a relational database. So what we're going to be doing, similar to a select statement, is we're going to be able to filter data that we don't want. In the select statement, you do that in the where clause, and we're going to be able to return only the attributes that we want, similar to the select clause in your select statement, what comes between the select and the from. The question is, what is going to be filtered before we get here, before the data gets transmitted from the source in the cloud, from our Dynamodb database, down to our computer. If you do a scan, then the entire table is going to be downloaded. And that's fine for our table because our table is 780 kilobytes or so. It's less than a meg, so that's not going to be a problem. But of course, in a big data world, that wouldn't be good. I mean, you might have a Dynamodb database that's several gigabytes, and you can't do that. So the query operation allows you to only select a subset of whatever items there are in this Dynamodb database. But the only way that you can select that subset is based on the primary key. So in other words, you can have ranges of the primary key, or you can be deciding what you will allow in your hash or your range or whatever. So there's operations that you can do to filter based on the primary key, but nothing else. And then once that gets downloaded to you, you can do some further filtering. Well, we're going to just do a scan. We won't bother with saying I'm only going to allow a certain part of the database to be downloaded, and then we're going to filter the results. So we're going to be doing this thing. And here's a link. These three links kind of tell you a little bit more about that. And you can kind of see what a scan is going to look like here. So I think what I'd like to do is we're going to create a script file, and we'll experiment a little bit with doing some queries. And as normal, I have to import Boto3. And actually, maybe I'll put a little label up on top, a little comment here. Querying Dynamodb DB database. And I'm going to import Boto3. And we're going to also need to import something else. You can see this import statement right here. Import, I'm going to copy it. So this is slide 29, by the way, of the PowerPoint. I'm going to copy it, and we're going to do this import right here. Actually, we really don't need key for the purposes for what we're doing. I won't even keep key, but we do need ATTR. So we're importing Boto3, which we've been doing already, giving us all of the access and functionality. But there's also a module in the Boto3 package hierarchy here called conditions. And we're going to start to apply conditions on these Dynamodb fields because we're going to be doing something equivalent to a where clause. And ATTR attribute, we're going to need that class. So we're going to make use of that. And I'm going to go ahead and save it. And I guess I'll just put it in my desktop, in my temp folder. And I'll call this one, query DynamoDB query. DynamoDB. And we have it. And if I run it, I should be able to run it without any problem. I should be able to import these things, and let's see what's going to happen. And it looks like I'm able to import these things without any difficulty, because we installed the Boto 3 library. So I think what I'm going to do is I'm going to just start off by just copying this query. So we're going to be scanning. We're going to be giving it a filter expression. I'm going to talk about filter expressions. We're going to see two kinds of expressions. We're going to see filter expressions, which is kind of like what the where clause is in a select statement. And we're going to see something else called projection expressions, which is kind of like what you have after the word select and before the table, before the from. So let me copy this, and I'll save it. And where's the Python shell? Well, let me run it, and the Python shell will come up. And there it is. Oops, I'm getting an exception. Table is not defined. Oh, I forgot to do some things. What did I need to do? I need to make a resource, and I need to make a table for that resource. Remember? So I'm going to say resource equal boto3.resource, and we're going to be making use of DynamoDB. And I say table equal resource and dot and capital T table, and the name of our table was AW product BOM. And now, if I did everything, I should be good. Let me try running it again. So I run it again, and now we're getting a lot of stuff out. So let's see what we're getting out here. And what we're getting out here is basically all of the mountain bikes. So let's take a look and see what we had for our scan. So scan is a function, a method that you can call with respect to a table. So we have this table, this DynamoDB table, which is composed of items, and those items have this composite primary key, which is the product ID and the product name, and also has whatever other data there might be. Remember, it could have anything you want in each item. Some items might have certain fields, and other items might have other fields. So in this case, all of our items had a product ID and a product name and a category and a subcategory, the way I created that JSON file to begin with. And so when we do a scan, and we are doing the equivalent of a where clause by passing an argument. So there's a lot of arguments that you can pass to the scan class, and these arguments, some of these arguments you can pass as named arguments. Remember, you can do that in Python. So there's an argument called filter expression. And filter expression is looking for a condition. And here's a condition. That's why we needed to import this stuff from conditions import attr. A condition on an attribute. And this particular condition was checking to see if the subcategory attribute is equal to mountain bikes. And so we only filtered just for mountain bikes. And so response gave us that response. So remember what response, we've gotten responses of a lot of things before. Let me do a response. Response is actually just the name of my variable, but we had responses from just doing a get. Now we have a responsible for doing from doing a scan. And if I look at response, it's going to be a pretty big thing, 2,300 lines, because it has all of this stuff in it. And not only does it have all of this stuff in it, remember, the response was getting all of the data. As a matter of fact, let me do this. Let me do the very last item. So we had for item and items. Let's see what that item is. That last item, the whole thing, and that's squeezed text of 75 lines. I'm going to take a look at it. Let me copy it and put it into Notepad. We'll take a look at what it looks like. And what do we have here? This has the product and its subcategory, all its attributes, and its entire bill of materials. So everything had come down. So we're getting only those items, however, that are mountain bikes. And we did that via this use of a filter expression. So with that in mind, I'd like to go a little bit further and let's experiment with doing some other queries. And in general, we're going to have a filter expression, and we're going to have perhaps a projection expression, because in this case, we got all the fields. In this case, we didn't have a projection expression. We just retrieved all of the attributes. It's like it was a select star. It was basically what we had. And you can see that. I kind of showed it to you. Let me just view it again. I kind of showed it to you. Select star was the entire record with all the data, including all of the bill of materials stuff, all the components and everything, the whole thing. Maybe you don't want to do a select star. So that's where our projection expression is going to come into play. And then the other thing we have to consider is what are the logical operators involved here? So you have things like greater than or equal to or not equal or things of that nature, and then you got your ands and your ors and your nots, and the same kind of thing that you're going to be concerning yourself with in a select statement, or for that matter, in an if statement, and in a programming language, you're going to be concerning yourself with here as well. So I'm going to put a couple of comments here so we have a little bit of an idea of what to expect. So first of all, what are the logical operators? So here's the logical operators. So if we had to do an AND, in this case we only had a single Boolean expression right here that we were evaluating. But what if we wanted to have AND something else or something else or something like that? So here's our logical operators. The AND operator is just the ampersand, single ampersand. The OR operator is a single vertical bar, which is called the pipe symbol. And then the NOT operator is the tilde, which should be all the way to the left of your keyboard there at the top, to the left of the 1 at the top is what I have, the tilde symbol. So we got AND, OR, and NOT. And then the other thing are what are the comparison functions that we did? Like here was equal. So here's our comparison function. So let me just list those up. Comparison and other functions. Yeah, I guess comparison functions should be what's with that. Yeah. So we have equal, we have not equal, we have greater than, we have greater than or equal, we have less than, we have less than or equal. And here's another useful one that we can make use of is contains. And so those are your logical operators and your comparison functions that we can be making use of. Now, as I said, for each query that we do, we're going to have a filter expression, probably. I would assume you want to filter out unwanted rows, or unwanted items, I should say. They're not called rows in Dynamodb. And we're going to also want to have a projection expression. Again, we might not want to see all of the attributes. So I'm going to put a little comment here. I'm going to put filter expression. And I'll tell you what I'm going to do here. And I'm also going to put a comment here. And I'll say projection expression. So for my query, I want to make this kind of a generic thing that I can easily change it and run it again and that sort of thing. So I'm going to have a filter expression, and I'm going to make that filter expression just be this condition here. So just in order to be able to be a little bit more flexible with this, I'm going to call it filter expression. FE is the name of my variable, and then I'm going to get this out of here. I'll just cut it out of here completely, and I'll put it into, oh, no, that's not what I wanted to do. I wanted to cut this part out, so the actual condition completely out of here, and I'm going to just put it right there. So here's my filter expression. My filter expression, and this is a Boolean expression that subcategory equals mountain bikes, and I'm just going to put in here FE. And I'll go ahead and run it, and we should get the same results. And it looks like we got the same results, only the mountain bikes, right? So I'm going to just be able to use this function and just do something like that with it. Now I'm going to do, now, let's say I don't want everything. Maybe I only want to get a few of the attributes from it. And again, let me look at item again. This was item, that last item. Let's look at a view of it again. It had all of the attributes. And let's say I didn't want to have all of the attributes. It had the entire item. Let's say I didn't want the entire item. I just wanted some of it. So there's something called a projection expression. So I'm going to say for my projection expression, just for the first one, projection expression equals, and then I'm going to have a string that contains basically just a list of a comma delimited list of things. So of the attribute names. Product name, product ID, product name, let's say list price. Okay. So this is going to be another argument that I pass to the scan function. So when I call it, I'm going to give it the filter expression, and another argument is projection expression equals PE. And this time, I think what I'd like to do is, I'll just comment out this print of printing the entire thing. This time, I think what I'm going to do is I'm just going to print the item and see what it does. And now it's printing each item, but notice that each item only has those attributes: the product ID, the product name, and the list price, which, remember, we had converted it into decimal in order to be able to allow Dynamodb to take it, because by default, what was in the JSON was float, so we had to do some playing around with it. So there you have it. So we have a filter expression, and we have a projection expression. Notice that the product name includes within it the color. You can see that, right? So I think what I want to do is I also want to focus, and I think I actually suggested doing this in the PowerPoint. Let's see. Only the black mountain bikes. So I want to focus only on the black mountain bikes. So now I want to do something where I'm going to not only be focusing on mountain bikes, but only focusing on those mountain bikes that have the word black in their name. So I'm going to use the contains function for the product name. And I'm going to combine that in this filter expression using the AND operator. So and let me just copy this. It's not going to be the same. So I'm looking at the product name here. The product name attribute contains is the comparison function, black. And I'm going to run it. And there it is. Only mountain bikes that are black. Let me also put out the subcategory as well, so we can make sure that these are only mountain bikes. So in my projection expression, I'm going to include the subcategory. Roy. And we should see that they are all indeed mountain bikes. Okay, it looks like they don't put them out in the same order as you have in your projection expression. See that product ID subcategory came before the name, before the list price in the name. I'm not really sure why that was the case. At any rate, that's what you got out of it. Each of these dictionaries is basically a piece of the source dictionary. Anything else I want to look at? We can do not. Let's do where it's not a mountain bike and the product name contains black. So I'm going to put a not here. Let me kill this shell here and I'll run it again. And we have a lot of things that have, we do have black. Oh yeah, it still has to be black. You're right, they're going to be black, but it's not a mountain bike. There are road bikes, there are mountain frames, there are all kinds of products here that have the word black in their name, but all we're seeing are the ones that are not mountain bikes with the not operator. So that's kind of in a nutshell how we do these queries. I will say this, though, that you can't, there's really not a mechanism that I know of for doing aggregation with queries. There's a little bit of a mechanism that you can at least see counts of things. Response, if I look at response, and I believe in response I have somewhere down here, count and scanned count. So toward the end of this big response dictionary, response was a dictionary, and it had these items, and that was what we were mostly interested in, right? But there were other things as well, such as the count and the scanned count. So the scanned count is telling us how many records came down in the first place, and remember, we took the whole table because the scan gives us the whole table. And the count tells us how many got through the filter. So there were 40 records that got through the filter. So we can get that, but we can't get things like sums and count and mins and maxes and things of that nature. So I think what I'm going to do is we'll just have to do that in our code. So what I'm going to do here is I'll just do an accumulator. And what I'm going to do is, and then I'm going to get maybe I want to get the average. Let's do an average. I want to get the average price. Okay. So I'm going to make a variable called average price. And I'm going to initialize it to 0. And each time in my loop, I'm going to add to average price the list price for that item. So I'm going to say average price plus equals, which is basically saying let's take what's already in it and then add to it, and then assign back into it this the list price. So item's list price attribute, which, if you'll recall, is a decimal. So I'm adding the average price, and then at the very end, I'm going to divide by the count. So average price is going to be divided by my response count, which, remember, that was an attribute of the response. I showed you that. And then I'll just print average price is average price. Let's see what it does. Put a couple of end of lines in here. And I'll go back to making it the mountain bikes, only on the mountain bikes, so we don't have so many rows. I'm going to run it, and we should see, oops, I wanted it to be /n. Let me do it again, run it, and there we have our average price. So what I was wanting to show you was that if we look at the type of item list price, we can see that it's a decimal. So we were able to do that. So that's kind of how we did our aggregation in this case. We had to do it in our code. Okay, I think I've covered all the basics of querying. Now I'm going to be asking you in your assignment to do a few queries using this kind of approach. And I'll put them in when I post that into the part of the assignment, and I'm going to do that. So you basically have the mechanism for doing that, and I'll have you do like maybe 3 or 4 queries on your own, and that'll be part of your deliverable as well. Now the next thing we're going to do is actually construct the bill of materials hierarchy, so we can display it and ultimately display it in graphical form as well. And this is going to require us to do something called recursion. And I'll talk about what recursion is. We don't really teach recursion in the 331. I don't think so. I'm not sure if it's been taught in 331 in the last couple or 3 years, but I didn't really teach it. But recursion is a very important thing for anything having to do with AI, and in particular anything having to do with tree processing. And what we're building is a tree, a hierarchy. And so we'll talk about that next time.